Again, welcome to another episode of EXO Reality. I'm your host, Christopher Carson. Let's talk about what's really happening when a Tesla drives itself. Not cruise control, not lane assist, where the vehicle is actively interpreting the world in real time and making decisions. Here's how it works. A Tesla doesn't rely on traditional radar or LiDAR the way many other autonomous systems do. Tesla's approach is vision-based only. The vehicle uses 8 external cameras positioned around the car to create a 360 field of view. These cameras feed continuous into onboard neural networks video. That means the car is not following a pre-programmed route. It is analyzing live visual data, just like a human driver, but processing it at machine speed. The cameras capture everything: lane markings, traffic lights, pedestrians, cyclists, vehicles, construction, cones, roadsides. The neural network then converts those images into a three-dimensional understanding of space. Tesla calls this occupancy network modeling, essentially building a real-time map of the world around the vehicle. Now here's where it gets advanced. The system is trained on billions of miles of real-world driving data. Every Tesla on the road contributes to improving the model. When drivers encounter edge cases, unusual traffic patterns, unexpected obstacles, rare scenarios, that data feeds back into Tesla's training system, so the car learns from collective experience. It's not memorizing roads, it's learning patterns. The vehicle runs this data through what Tesla calls its full self-driving computer, a specialized hardware designed specifically for neural network inference. This allows the system to make split-second decisions about steering, acceleration, braking, and lane changes. Now let's break down detection. The neural networks identify objects and classify them: pedestrian, vehicle, traffic signal, lane boundary, debris, emergency vehicle, and so on. But beyond identification, the system predicts movement. If a pedestrian is standing near the curb, the car calculates probability. What is the likelihood that this person steps into the traffic? If a vehicle ahead slows down slightly, is it preparing to turn? Is traffic compressing? This predictive modeling is critical. It's anticipating. Tesla's system also handles traffic lights and stop signals through visual recognition. It determines signal state, red, yellow, green, and integrates that into navigation planning. It doesn't just see the light, it incorporates it into route decision-making. Navigation itself is tied to high precision mapping and GPS, but the car is not blindly following a static map. It constantly cross-checks map data against live visual input. And yes, driver monitoring is part of the system. Even in full self-driving mode, Tesla requires driver supervision. Interior cameras monitor attentiveness. If the driver looks away too long or removes hands from the wheel without periodic confirmation, the system disengages. Now here's the bigger shift. Traditional automation follows rules. Tesla's approach is neural network-driven autonomy. That means instead of coding every possible driving rule manually, engineers train a model to interpret and respond dynamically. It's closer to how humans learn. But the implications extend beyond driving. When you watch a Tesla navigate a busy urban intersection without human input, you're watching machine perception operate in the physical world. That's significant. The system is solving real-time spatial reasoning, probabilistic forecasting, motion planning, and risk assessment continuously. Driving is one of the most complex daily tasks humans perform. If AI can manage that environment at scale, we are witnessing applied intelligence, not theoretical intelligence. And here's the question we should be asking. When autonomous systems statistically outperform human drivers, does responsibility shift? Does trust shift? Does infrastructure evolve around machine decision-making? Tesla self-driving isn't just a feature. It is a live experiment in distributed machine agency operating on public roads. Every mile adds training data. Every update refines the model. This isn't incremental technology. It's compounding intelligence deployed in motion. And that's why self-driving is important. Not because it's convenient, but because it demonstrates that the physical world is becoming programmable. This is EXO Reality. Have a wonderful evening, and remember to like and subscribe.